Good morning, students. Welcome to the maths class. Today I am going to explain exercise 8E of differentiation. In this exercise, you are going to study differentiation of exponential functions. So, differentiation of exponential function means differentiation of e to the power x d upon dx of e to the power x first, and second d upon dx of a to the power x. Differentiation of exponential functions means differentiation of e to the power x and differentiation of a to the power x. Differentiation of e to the power x is e to the power x only. Differentiation of a to the power x means a to the power x log a to the base e, where a is greater than 0 and a is not equal to 1. So these two things you have to remember for this exercise. Only two differentiation you have to keep in the mind. Differentiation of e to the power x is equal to e to the power x. Differentiation of a to the power x equals a to the power x log a to the base e, where a is greater than 0 and a is not equal to 1. So these two formulae, these two differentiation you have to keep in the mind, and you start the exercise. Then you can do all the questions of exercise 8E. And that chain rule also you have to keep in the mind. Chain rule from first exercise it is going on. So now I am taking some examples. Example number 15. In this example there are 15 parts, but first 8 parts I will take. So you see how to solve. In first part it is given you have to find differentiation of x to the power 8 plus 8 to the power x. X to the power 8 plus 8 to the power x. This function you are taking as y. Let y equals x to the power 8 plus 8 to the power x. Then dy upon dx equals, now x to the power 8, differentiation x to the power 8, you can do 8x to the power 7. You can see, because you know differentiation d upon dx of x to the power n equals n x to the power n minus 1. In first exercise I told you, so everyone knows about it. So now you can see differentiation of 8 to the power x. 8 to the power x means a to the power x. In two differentiation I told e to the power x and a to the power x. A to the power x, I told you a can be any positive number but not equal to 1. And in case of e will be a fixed number, a rational number, 2.178 something, its value of e. So if 8 to the power x is given, 5 to the power x is given, 9 to the power x is given, so you have to apply the differentiation a to the power x. So 8 to the power x means 8 to the power x log a to the base e. According to a to the power x, 8 to the power x differentiation 8 to the power x log a to the base e. Next part. Second part, you have to find differentiation of e to the power sin x. E to the power sin x, again I am telling, by applying chain rule, e to the power x, you will take it as e to the power x. So e to the power x differentiation is e to the power x. So that's why they are giving differentiation of e to the power sin x, e to the power sin x multiplied by d upon dx of sin x. Why d upon dx of sin x? Because we have taken it e to the power as x, but it was not x, so its differentiation it will come in multiplication. So e to the power sin x multiplied by d upon dx of sin x. So e to the power sin x multiplied by cos x, so cos x into e to the power sin x. Now third part, you can see e to the power x square. So e to the power x square you can take it as e to the power x. E to the power x differentiation is e to the power x in multiplication d upon dx of x square will come. Just before I told you x square differentiation is 2x. So 2x e to the power x square, it will be the final differentiation. Fourth part you can see e to the power 10ax. So e to the power 10ax differentiation is e to the power 10ax multiplied by d upon dx of 10ax, because it was not x. 10ax is not x, so its differentiation again it will come. Again and again in every video I am telling this chain rule, so you have to understand this. E to the power 10x, now 10x differentiation sec square ax. Now ax differentiation a. So finally it will come a sec square ax e to the power 10 ax. Next part you can see, fifth part, differentiation of a to the power under root 1 plus x square. So you can take it as a to the power x. So a to the power x differentiation, a to the power x log a to the base e. So a to the power under root 1 plus x square log a to the base e, you can see. Now after this, in multiplication, d upon dx of under root 1 plus x square, and its differentiation, you know, 1 upon 2 under root 1 plus x square. You can see a to the power 1 under root 1 plus x square log a to the base e multiplied by 1 upon 2 under root 1 plus x square. Now differentiation of 1 plus x square, that will be 2x. So you can see here a to the power under root 1 plus x square log a to the base e into 1 upon 2 under root 1 plus x square into 2x. Now 2 will cancel, you can see here. So what will come? X upon x, you can write it x log a to the base e upon under root 1 plus x square a to the power under root 1 plus x square. Like this you can write this. So it is given x upon under root 1 plus x square log a into a to the power 1 plus x square. Next part you can see, sixth part, tan to the power log sin x. Tan to the power log sin x. So first of all, tan to the power x you can take, so tan to the power x log 10 to the base e. So tan to the power log sin x log 10 to the base e. Now in multiplication, d upon dx of log sin x. Log sin x you can deal it as log x. So 1 upon x. So 10 to the power log sin x, log 10 to the base e into 1 upon sin x, because x is here sin x. And now differentiation of sin x is cos x. So cos upon sin is cot x. So cot x log 10 to the base e into 10 to the power log sin x. They are giving cot x 10 to the power log sin x into log 10 to the base e. Log 10 to the base e you can write like this also, you can write cot x log 10 to the base e into 10 to the power log sin x. Like this also you can write log sin x. Now part 7th. In 7th part it is given e to the power 2 log 10 5x. First of all, this power you will take with log 5x, with 10 5x. So it will become simplification, it is just simplification. E to the power log 10 5x to the power 2. It is the law of logarithm. I told you n log m equals log m to the power n. N log m equals log m to the power n. With this rule you are writing e to the power log 10x whole square. Now this rule you have to remember, it is new thing for you. If e to the power log x, here you can see e to the power log x fx is given, then directly you can write it fx. So here you can see e to the power log 10x 10 5x whole square is given. So e to the power log, they will adjust themselves and 10 5x whole square will come final answer. Whenever it comes you have to do like that, e to the power log something, so e to the power log they will adjust, and whatever something is written, that will be the final answer. So 10 5x whole square, it is the final answer. Now differentiation of 10 5x whole square you have to find. So differentiation of 10 5x whole square, 2 10 5x because x square like x square you are doing its differentiation. So 2 10 5x, now 10 5x differentiation, sec square 5x, now 5x differentiation 5. So 5 2s are 10, so 10 10 5x sec square 5x. Now one more part, 8th part. Now this is written under root 1 plus e to the power x upon 1 minus e to the power x. So under root you can take separately. Under root 1 plus e to the power x upon under root 1 minus e to the power x. Now you can apply u upon v formula. So v square in denominator you can see here, under root 1 minus e to the power x whole square. Now v same, under root 1 minus e to the power x is same. D upon dx of u. So u is d upon dx of under root 1 plus e to the power x. Then minus sign comes, minus is there. U same, u means under root 1 plus e to the power x. Then in multiplication, d upon dx of v. So d upon dx of, you can see d upon dx of under root 1 minus e to the power x. Now when you differentiate, you can see this is same, it is written. Now differentiation of this under root x, 1 upon 2 under root x, 1 upon 2 under root 1 plus e to the power x. Now differentiation of 1 plus e to the power x, e to the power x, minus this is same, under root 1 plus e to the power x same, under root x again, 1 upon 2 under root x, 1 upon 2 under root 1 minus e to the power x. Now 1 minus e to the power x differentiation, minus e to the power x. Now in denominator square root will cancel because whole square is there. Now you can see how can you simplify. You can take e to the power x upon 2 common, e to the power x upon 2 common, you can see. Now you will have under root 1 minus e to the power x upon under root 1 plus e to the power x, plus minus minus plus, this minus and this minus, plus. So under root 1 plus e to the power x upon under root 1 minus e to the power x. Now take LCM. When you take LCM, then it will be 2 under root 2 is this outside 2, and when you multiply under root 1 plus e to the power x under root 1 minus e to the power x, so it will come under root 1 minus e to the power 2x. A plus b, a minus b formula you can apply. In numerator it will come, under root will cancel, this will be multiplied, this will be multiplied. So 1 minus e to the power x plus 1 plus e to the power x. E to the power x will cancel. So 1 plus 1, 2. 2 will also cancel. So 1, 1, 2 and 2 cancel. Final answer is e to the power x upon under root 1 minus e to the power 2x. You can see e to the power x upon 1 minus e to the power x into under root 1 minus e to the power 2x. I think it is clear to you. So these were the examples. Some other parts you can see from the book, solution of other parts from 9th to 15th. And after this you can start exercise 8E, and I hope you have understood all the things which I explained, and I hope you will do all the questions given in exercise 8E. If any problem comes, then you can ask in comment. I will clear your doubts. Thank you and have a nice day.